We are going to solve the example number 2 with the help of a bisection method, and we have a question that we need to find the roots of an equation, that is our nonlinear equation, and with the help of a bisection method correct up to 3 decimal places. So we need to achieve the accuracy to the 3 decimal places, and we are given with a function that is basically a nonlinear equation. So but we are not provided with the interval. So first of all, we need to find out the interval with the help of a hit and trial method. And after that, we will apply the bisection method on that. So in order to proceed towards the solution, we need to apply the hit and trial method. And according to hit and trial method, we need to substitute the value starting from 0 into that function in order to get the two values that gives us two function values that gives us an opposite signs on two specific values. So if I start putting my value from 0, so we will get 0 cube minus 0 minus 4. So I'll get negative of 4, that is less than 0. Next, I'm going to substitute 1. So if I put 1, so I will get 1 minus 1 minus 4. So I will get negative of 4. So again, this is less than 0. Now it's mean that we are not allowed to choose 0 and 1 interval because both giving us a negative sign. So we need to go for 2. So if I substitute 2 raised to cube minus 2 minus 4, so I will get 8 minus 2 minus 4. So that is equals to 2, that is greater than 0. Now we have two options. Number one is that we choose 0 and 2 as an interval. Second option we have that we choose 1 and 2 as an interval, as an initial guesses actually. So on that interval, first one, 0 gives us a negative value and this positive, and here we have negative and positive. So it means that roots are bracket. There is one root that lies between in the interval. But I recommend you that whenever you are solving the numerical solutions or numerical methods, you need to choose a smaller interval. If you choose a smaller interval, your number of iterations will also be reduced. So for that purpose, I am choosing the middle value from 1 to 2. So I target at 1.5. So when I substitute 1.5 back into this function, I will get the value negative of 2.125. So that is less than 0. So we need to proceed toward the positive side. So we need to substitute next value in order to find out the pair. So 1.6, we will get again negative 1.504 less than 0. Next negative we got. So next I'm going to find out 1.7. So I'll get negative of 0.787. That is also a less than 0. Next I'm going to substitute 1.8. And on 1.8, I am going to find 0.032, that is a greater than 0 value. So for the solution of this question, I am choosing an interval 1.7 and 1.8. On 1.7, I am getting a negative value, and on 1.8, I am getting a positive value. The reason of choosing this interval, because the size of that interval is very small, and if we choose a very small interval, the number of iterations will be reduced, right? So for solving that question, I am using this interval in order to proceed the question. So let's apply the bisection method. So we are going to perform our first iteration. So x1 is equals to 1.7 plus 1.8 and divided by 2, and we will get 1.75. Now we need to substitute in a function in order to examine the sign. So 1.75, so our function would be changed to cube minus 1.75 and minus 4. Yes, that is the function. basically a nonlinear equation. So when we solve it, we will get negative of 0.39. So it means that f of x1 is less than 0. So root lies between. Now we need to change the interval. Basically, we need to update it. So this is the negative sign. So we are going to update on the 1.71 on the negative side, and the positive side will remain unchanged. Next, we go for the second iteration. And we need to keep in mind that we need to achieve the accuracy till 3 decimal places. So x2 is equals to 1.75 plus 1.8 divided by 2, and the result would be 1.775. So now we substitute in a function that is 1.775 in order to examine the sign. So the answer would be negative of 0.182. Since f of x2 is less than 0, so root lies between, we have the interval, we need to update on a negative side. So this is 1.775 comma 1.8. That is our updated interval. So we go for the more iterations. This is the third iteration we are performing. We have x3 that is equals to 1.775 plus 1.8 divided by 2, and we will get the results 1.7875. Now we substitute into a function in order to examine the sign. 1.7875 cube minus 1.7875 minus 4. So we will get the result negative of 0.076. Since f of x3 is again less than 0, so we need to update our result on the negative side of the interval. So our updated interval will be 1.7875 comma 1.8. Okay, so we need to go for the fourth iteration. Still, we need more iterations because we didn't achieve the accuracy yet. So x4 that is 1.7875 plus 1.8 divided by 2, and we will get 1.79375. So we need to substitute the value into a function. 1.79375 raised to cube minus 1.79375 minus 4, and the answer would be negative of 0.022. Okay, so again we get a negative result. So x4 less than 0, so we need to update in negative side. So we will get 1.79375 comma 1.8. Now we need to update. After updating, this is our updated interval. So we need to go for fifth iteration. So x5 is equals to 1.79375 plus 1.8 divided by 2, and we will get the solution 1.796857. Now we substitute in a function in order to examine the results. So 1.7968 1.75 raised to cube minus 1.796875 minus 4. So we will get 0.0048. That should be greater than 0. So since the f of x5 is greater than 0, so we get a positive result. So we need to update our interval. So the negative side should be same, that is 1.79375, and we need to update on positive side and we will get 1.796875. Okay, now we need to go for more iterations. The reason is that we find the accuracy to 2 decimal places. So as it is mentioned in the question, we need the accuracy till 3 decimal places. So we need to go for more iterations. So let's proceed to the 6th iteration. So x6, that is equals to 1.79375. This is 506 plus 1.796875 divided by 2. So when we simplify it, we will get 1.795312. So we need to substitute in a function that is equals to 1.795312 cube minus 1.79531 to negative of 4. So we will get negative of 0.0087, that is less than 0. So again we need to update our solution. So since f of x6 is less than 0, so root lies between, so here we have negative, so we need to change in on the negative side. So 1.595312, that is our updated result, and this is our previous result. So still we have the accuracy till 2 decimal places. So we need to update, we need to go for another iteration, that is a 7th iteration. So x7, that is equals to 1.795312 plus 1.796875 divided by 2, and we will get the answer 1.796093. Now we are going to put back in a function in order to examine the sign. One 1.796093 raised to cube minus 1.796093 and negative of 4. So we will get simplified result to negative of 0.000199. So f of x7 less than 0. So root lies between, this is a negative, so we need to write 96093 and 1.796875. Okay, if we look at the results, so we achieved an accuracy to 3 decimal places. This is 1.796 and this is 1.796. So we write it that hence the approximate root correct up to 3 decimal places is x is approximately equals to 1.796. So, yes, that's how we solve the problem using a bisection method. I hope this step-by-step explanation make things easier for you. If you found this helpful, don't forget to like, share, and subscribe to the channel for more numerical analysis tutorials. And if you have any questions or want me to cover a specific topic, drop a comment below. I would love to hear from you. Thanks for watching, and I will see you soon in the next video. Take care.